Good morning, class 12 science. Today you are going to start the last chapter of physical chemistry, that is surface chemistry. Okay. In this chapter, we are going to discuss about the topics that we need to discuss is absorption, adsorption. Okay. You can see the difference between it. This is B and this D. Absorption and adsorption. Differences between them and factors affecting adsorption. And after that we'll discuss about the catalyst as well. Okay, catalysis. Okay, now so the chapter name is surface chemistry. Surface chemistry deals with the phenomenon that occur at the surface or interfaces. So the process or the phenomenon which occurs at the surface, we call it as such a study we call it as a surface chemistry. The interface or surface is represented by separating the bulk phases by a hyphen or slash. So say for example, if you have got a solid and gas, then the interface or the surface between them can be represented by solid gas like this, solid slash gas, or by hyphen. Okay. Now we have to understand these two important terms, absorption and adsorption. What is the difference between it? Okay. The process in which the substance is uniformly distributed throughout the bulk of the solid is known as absorption. So in absorption, the whole substance, or we can say the substance, is uniformly distributed outside as well as inside also. And the process in which the substance is concentrated only at the surface, okay, and does not penetrate through the surface to the bulk of the adsorbent. Okay. Adsorption means the process which takes place only at the surface and it does not go inside or penetrate inside the bulk. So that is adsorption. Say for example, let us understand with the help of an example what is this absorption and adsorption process. So when a chalk stick is dipped in ink, okay, then the surface retains the color of the ink due to adsorption of colored molecules, while the solvent of the ink goes deeper into the stick due to absorption. So when you dipped a chalk stick in ink, what will happen? The surface of the chalk will retain the blue color. That process is adsorption. But that blue color you will not find inside. Whereas you can find the solvent, that means the weighted portion of that chalk inside it also, and that process is absorption. Okay. The factors affecting adsorption. What are the factors that are going to affect the adsorption process? Surface area. That means more the surface area or higher the surface area, more will be its adsorption power. Nature of gas, it depends on the nature of gas as well. Temperature, so adsorption will be affected by the change in temperature as well, and pressure as well. Now there are two types of adsorption, physical adsorption and chemical adsorption. Now let us see what are these two adsorption. When the gas molecules are held on the surface of a solid due to van der Waals forces, the adsorption is termed as physical adsorption or physioadsorption. So when the gas molecules are held to the solid due to weak forces like van der Waals forces, such adsorption we can call it a physical adsorption. And chemical adsorption means when the gases molecules or atoms are held together to the solid surface by chemical bond. By chemical bond, the adsorption is termed as chemical adsorption or chemisorption. So this is the difference between physical and chemical adsorption, we can say, as well as their definition. Now next topic after adsorption, we have got catalysis. Okay, we know the term called catalyst. A catalyst is a substance which alters the rate of reaction without being used in the reaction and can be recovered chemically unchanged at the end of the reaction. That means a catalyst is a substance which can change the rate of reaction but itself remain unchanged at the end of the reaction. So, and the reaction which involves catalyst is known as catalysis. So, a catalyst, either it can increase the rate of the reaction or it can decrease the rate of the reaction. So, the catalyst which increases the rate of the reaction is called a positive catalyst, and the catalyst which decreases the rate of the reaction is called a negative catalyst. So, positive catalyst, it lowers down the energy of activation of reaction and accelerates the reaction. Example, KCl3, this is the laboratory preparation of oxygen. So in the laboratory preparation of oxygen, potassium chlorate is heated in presence of a small amount of manganese dioxide, which is act as a catalyst to form potassium chloride and oxygen. Similarly, negative catalyst means the catalyst which decreases the rate of the reaction. Okay, so for example, TL, that is tetraethylate, decreases knocking of petrol and thus acts as a negative catalyst. Or another example is the oxidation of chloroform in presence of air is retarded in presence of alcohol. So when chloroform is exposed to sunlight or air, we know that it is going to form a very poisonous gas, that is phosgene, that we have studied in organic chemistry. So in order to prevent it, we add alcohol. So this alcohol function is to decrease the rate of the reaction, we can see. So types of catalysis, we have got two types of catalysis. One is homogeneous catalysis and other is heterogeneous catalysis. Now, what are the terms? Homogeneous means same. What is same over here? Now, when you take the reactant and the catalyst phase same, that means state same. So for example, if you are taking the reactant solid or liquids or gas, and if you take the same state, then we can call it a homogeneous catalysis. Say for example, the definition tells us when the reactants and catalysts are in the same phase and the reaction system is called homogeneous throughout the reaction. Example, sulfur dioxide when treated with oxygen in presence of nitric oxide, which is a catalyst, it forms sulfur trioxide. Okay. Now in this process we can see that the reactants and the catalysts are in the same state, that is gases. So such kind we can call a homogeneous catalyst. Similarly, hydrolysis of ester in presence of mineral acid. This is an ester. When you treat with water, this is liquid, this is liquid, and if you treat with mineral acid, which is also liquid, it is going to form acid and alcohol. Okay. Similarly, hydrolysis of cane sugar in presence of mineral acid. So the homogeneous catalyst means where the reactants and the catalysts are in the same phase. Now, heterogeneous catalyst is when the reactants and catalysts are in different phases. The catalyst is known as heterogeneous catalysis. In most cases, the catalysts are in solid state while the reactants are in gaseous or liquid phases. Say for example, in manufacture of ammonia, that is Haber's process, we have got hydrogen and nitrogen in the ratio of 3:1, which reacts in the presence of finely divided iron, and molybdenum also is added to increase the efficiency of the catalyst to form ammonia. Now in this, if you see, we have got the reactant gases, but the catalyst that we are using is solid, so they have got the different phase. So such type of catalysis we can call say heterogeneous catalysis. Similarly with this one also, sulfur dioxide and oxygen giving sulfur trioxide in presence of platinum, and oxidation of ammonia by oxygen in presence of platinum, that is also a heterogeneous catalysis. Now assignment for today, that will be assignment number 9, continuation from previous assignments. Question number 1, differentiate between absorption and adsorption with the help of an example. Question number 2, mention the factors that affects adsorption. Question number 3, write down the differences between physical and chemical adsorption. Question number 4, define positive and negative catalyst, give examples. And question number 5, differences between homogeneous and heterogeneous catalysis. Complete this assignment and send it in my mail.